Hello, Mr. Almeida. I am Alisson Parraga and I'm going to present my demo class. This is my syllabus. This is the syllabus, the English for geophysicists, as teacher Parragalino Alisson Fernanda. This is the general information about the subject of geophysics. And the second point is the specific data about the subject, contribution, and subject characteristics. Then we have the syllabus structures. This course is composed for 4 units. The unit that I chose for this demo class is the seismology. Seismology is composed for 4 lessons. I chose the lesson 1.1, Introduction to the Seismology. The learning outcome is to study of earthquakes and seismic waves to understand the Earth's internal structure. And this is the next units. And finally, we have the lesson plan. In the lesson plan, I use as tool a Padlet, 2 videos from YouTube. I use Canva to do the slides and present through Canva. I'm going to use 2 games in EducaPlay to develop some activities. Hello students, welcome to this class. But before to start, I want to ask you the following question. Have you ever been during an earthquake? How was your experience? For answers these questions, you are going to explain or share your experience in Padlet, right? Now I'm going to share the link to write your experience, right?
Okay.
Okay, Karen. Can you share your experience?
Okay. In April 2016, Ecuador experienced a devastating earthquake registering a magnitude of 7.8 in Richter scale. That was a terrible experience because at that moment I was alone in my house and suddenly everything began to tremble. It was a very traumatic moment for me, and thank God I couldn't go out in time to a safe place.
Yeah, that is a good idea. Find a safe place to save to yourself your life. And Jesus, what about you? How was your experience during an earthquake?
Sure, miss. When I was 17, it was my first experience in the 2016 earthquake. I was leaving to get a haircut with a friend. Then I was walking through downtown Palmer. I feel as if my blood pressure had dropped because in the previous I don't do experience.
Thank you, Jesus. Each of us have a different experience about an earthquake. And in my case, during the earthquake in Ecuador in 2016, I was in the park with my little sister. And that moment was a little frustrated because I didn't understand what was happening in that moment. And at the beginning, I imagined that it was a little tremble, or I think, or I have high level of cholesterol. But when I returned at home, I heard that the devastating news of the earthquake in Ecuador, specifically in Pedernales, Manabí. So, by the way, the topic for today is the seismologic. This is the topic for today. Introduction, the seismology. But what is seismology? Please pay attention to the video. Can you listen to the video?
Yes.
As you see in the video, seismology is the branch of the geophysics that deals with the study of earthquakes and seismic activity, as related phenomena such as seismic waves. And this is important to list in understand the Earth's seismic activities in order to assess mitigate risk, design resistant structures, and contribute to the public safety. In addition, seismology provides crucial information for understanding the Earth's internal structure and geodynamic processes affected it. The Earth has a larger structure with distinct compositional and precision layers. The layers from the outermost to the innermost are the crust, mantle, the structure of the Earth is the crust, mantle, the outer core, and the inner core. So, Jesus, can you read?
Yes, Miss. Crust. Compositions. The Earth's outermost layer is the crust, which is composed mainly of rocks, minerals, and soil. Types. The Earth's crust can be divided into two types: the continental crust, found under land masses, and the oceanic crust, found beneath the ocean floors.
Thank you, Jesus. This is the first part of the structure of the Earth. The Earth structure is often compared with the structure of an egg, with the crust corresponding to the eggshell and mantle to the egg white and the core to the egg. Well, this layer structure plays a crucial role in geological process, including the movement of tectonic plates, volcanic activity, and the generation of the Earth's magnetic fields. And the last part is the outer core and the inner core. Can you read the outer core, Jesus, please? Can you read the outer core?
Sure, Miss. Outer core composition. The outer core is a primarily composed of liquid iron and nickel state. It is in a liquid state due to the high temperatures and pressures found in the Earth's interior. Roll. The movement of molten iron and nickel in the outer core generates the Earth's magnetic field through the geodynamo effect.
Thank you, Jesus. And Karen, can you read the next core? The inner core.
Composition. The innermost layer is the Earth's core, primarily composed of solid iron and nickel. Despite extremely high temperatures, the inner core remains solid due to the intense pressure at this depth. Well, the inner core is critical in maintaining the overall stability and structure of the Earth.
Thank you, Karen. So another important part of the seismic of the Earth is the seismic waves. We have two different seismic waves, the body waves and the surface waves. Seismic waves are the vibrations that travel through the Earth and as a result of something energy relates, typical from the geological phenomena such as earthquake, volcanic activity, or human activities like explosion. These waves carry information about the Earth's interior and are crucial for seismologists to understand the structure and composition of the planet. The seismic waves are the principles of when you feel a earthquake, it's the subduction of the tectonic plate into another tectonic plate. When the subduction of the tectonic plates is so strong, occur an earthquake, right? To better understand the body weights and the surface weights, we're going to see a video, right?
The shifting rock in an earthquake causes vibrations called seismic waves that travel within Earth or along its surface. Scientists use an instrument called a seismograph to record data about seismic waves. This yields information that can help scientists learn not only about earthquake behavior, but also about the structure of Earth itself. There are two broad classes of seismic waves: body waves and surface waves. body waves travel within the body of Earth. They include P, or primary waves, and S, or secondary waves. P waves cause the ground to compress and expand, that is, to move back and forth, in the direction of travel. They are called primary waves because they are the first type of wave to arrive at seismic recording stations. P waves can travel through solids, liquids, and even gases. S waves shake the ground in a shearing or crosswise motion that is perpendicular to the direction of travel. These are the shake waves that move the ground up and down or from side to side. S waves are called secondary waves because they always arrive after P waves at seismic recording stations. Unlike P waves, S waves can travel only through solid materials. After both P and S waves have moved through the body of Earth, they are followed by surface waves, which travel along Earth's surface. Surface waves travel only through solid media. They are slower moving than body waves, but are much larger and therefore more destructive. The two types of surface waves are named love waves and Rayleigh waves after the scientists who identified them. Love waves have a horizontal motion that moves the surface from side to side perpendicular to the direction the wave is traveling. Of the two surface waves, love waves move faster. Rayleigh waves cause the ground to shake in an elliptical pattern. This motion is similar to that observed in ocean waves. Of all the seismic waves, Rayleigh waves spread out the most, giving them a long duration on seismograph recordings.
In the video, we can understand that seismic waves are detected and recorded by seismometers and also known as seismographs, which are sensitive structures that can pick up the ground motion caused by these waves. By analyzing the arrival times and characteristics of seismic waves, the various locations. Seismologists can determine the important information about the earthquake sources, such as its location, depth, and magnitude. Additionally, seismic waves help in studying the Earth's interior structure through a process known as a seismic tomography, right? And now we are going to analyze some terminologies about the seismic, right? So let's start. These are some terms that you are going to find during this course about the seismologies, right? So first you are going to analyze the terminology and then the meaning of the terminology, right? First we have the biosphere. What do you think about biosphere? What it's the meaning of biosphere? Karen, can you tell me?
An animal live is the last sentence.
Like this?
Yes.
Right, Karen. Jesus, atmosphere, where it
Atmosphere contains oxygen.
contain the oxygen. Right, the magma. Where is the magma? This is part of the structure of the earth. This is in the center of the earth. Karen, where is the magma?
The concept of magma is large bodies of earth.
This?
Yes, miss.
Are you sure?
Yes.
Thank you, Karen. Jesus, lithosphere.
Lithosphere is crust and uppermost model.
Right. And the next is the mantle. Mantle is another part of the structure of the earth. Karen, what is the mantle?
Layer between the crust and the core.
Layer between the crust and the core. Right, Karen. Last is crust. Crust. What is crust, Jesus?
Crust for me, outermost layer of the earth.
Outermost layer of the earth. Thank you. The core. We did talk about the core in the previous slides, right? What is core, Karen?
The core is in the first sentence, innermost part of the earth.
Right. The continental drift. Jesus, what is continental drift?
For me, I think is the theory that explains the movement of Earth's continents.
Obviously, the continental drift is the Earth's continent, the movement of the Earth's continents, right? The hydrosphere, then the similar word, the hydrosphere. What is the meaning? The water. Hydrosphere, water. It's the part of water of the earth that we know that the majority of our earth is composed by water, right? Thank you. So now, for the last activity, you are going to identify the structure of the earth, right? I'm going to tell the name. For example, this is the oceanic crust, and you're going to identify what is the oceanic crust. I'm going to say that this is a square 1, 2, 3, 4, 5, 6, and 7. And you're going to tell me what is the number of the square corresponding of the oceanic crust, right? Jesus, the first oceanic crust. What is the oceanic crust? 1, 2, 3, 4, 5, 6, or 7?
I think is the number 7.
Number 7. Thank you, Jesus. And Karen, the crust. What is crust? 1, 2, 3, 4, or 5? 6.
Repeat the number.
1, 2, 3, 4, 5, and 6.
Number 3.
Number 3. Thank you, Karen. Lower mantle. Jesus, lower mantle. Did you remember what is the lower mantle?
I think is the number 5.
1, 2, 3, 4, 5. This?
Yes.
Thank you, Jesus. Karen, what is the core? Where is the core? Number 1, 2, 4, or 6? 1, 6. Excellent, Karen. Jesus, the upper mantle. 1, 2, or 3? We have only 3 options.
Number 3.
Number
Number
3,
3.
the upper mantle. Thank you. Karen, atmosphere. Atmosphere. What is the atmosphere? This is a really important part of the structure of the earth. What is atmosphere? We have only 2 options. Number 2 or number 2? Number 1 or number 2, sorry.
Number 1.
Number 1. And the last, we have the continental crust. This is obviously the continental is composed by the continents of the earth, right? The continental crust. So for the last class, you're going to read about this topic. This is the topic for the next class. The next class is on Friday. I'm going to see you on Friday. And I need that you read about the geomagnetism and paleomagnetism. This is an interesting topic to better understand the structure on the earth and what are the resources that the earth shared with the human beings. So that's all for today. Have a nice day, guys. Thank you for starting this class. Thank you, guys.
Thank you,
Thank you,
Miss.
Miss.